So let's look at some of the particularities of digital technologies, the particularities that change and shape the way we are doing things in the digital age. One of the biggest innovations of digital ICT is that it brings three previously distinct technological trajectories together on one common standard, which is the informational bit. So, for example, as first, we have the trajectory of communication technology. We talked about that sufficiently, the telegraph, for example, the telephone, but that was even preceded by smoke signals, which was one of the first tele distance communication technologies. Trumpets and horns, for example, bugle calls, this. These were basically telecommunication technologies, right? So they had a long trajectory, they had a long coming, and before they went into digitization. The same happened with storage technology, starting with wall paintings, paper, the printing press. Now, both of them converged and both of them started to use digital bits to transmit information through space. We call that communication, and to transmit information through time. We call that storage. You transmit it through time for later usage. So both of them now converged on the informational bit. And a third one is computation. You also saw that. That's a transformation of information in space and time, and that also uses bits. The person who invented the bit is this person here, Claude Shannon. In 1948, he wrote a paper that conceptualized information as the opposite of uncertainty, which makes intuitively sense, right? If you have uncertainty, you don't have information. And if I give you information, it reduces uncertainty. Starting from this definition, he said, well, uncertainty can be quantified in probabilities, in probability theory, therefore, and therefore I can measure information in terms of how much uncertainty is reduced. He said that if uncertainty is reduced by half, that's what we call a bit. So a bit is a metric that quantifies how much uncertainty is reduced, and usually it's represented with a 1 or a 0, right? So you reduce uncertainty by half, you need two different digits, 1 or 0. What's the half of the coin during the coin flip? So that's where the bit actually comes from. The theory behind it is called information theory. The genius idea behind this theory led to the fact that we were able to improve telecommunication technology a lot, storage technologies a lot, and computation technologies a lot, and they all use the bit. Shannon proved that the bit, the binary representation of information or of uncertainty reduction, is the most efficient way information can be represented. So everything started to converge on the bit. And this had important implications, for example, on our perception of time. Through digital communication, we can now communicate in real time through very advanced telecommunication. We can have a video conference or we can have a chat. We can also do synchronous communication. That means that a computer tells us when to get together and when to update our communicational exchange, or we can have asynchronous communication. That is possible through a marriage of communication technology and storage technology. For example, I post something on Facebook and you can look at it at 3 o'clock in the morning. Or I actually don't know what time it is right now when you're watching this video, which I recorded, put it on a storage device, and then through intermediate storage, communicated it to you, and you are now consuming it. So the marriage of storage, communication, and computation led to a completely different way with which we can manage time. It also affects the directionality of our communication patterns. Before the digital age, we had to decide if we want to opt for technology that facilitates a one-to-one communication, for example, through a telephone or personal letter, or if we want to opt for technology that facilitates a one-to-many communication, for example, a newspaper or the printing of a book or broadcasting, radio, television, which is a one-to-many communication. Then we can also have a many-to-one communication, for example, through election or applause or a survey. That's when many communicate something to one, or a many-to-many communication, which is basically implemented by meeting up. Now, in the digital realm, we can do all of that. We can write an email one-to-one. We can broadcast something on a social network. We can do election or browse. We can get feedback, a lot of feedback. For example, if you press like on some comment, or we can have, a video conference where many people participate. So that kind of like destroyed the structure, because now we can do all of them in the same channel. We have polydirectional networks, for a better word of it. That means multiple directions in which we can communicate through digital channels. It also changed our perception of space. So not only the perception of time, but also our perception of space. Manuel Castells calls this the space of flow that was created. Why is it a space of flow? It's because Manuel Castells says that the geography basically doesn't matter so much anymore. I can instantaneously communicate with somebody on the other end of the globe, going through networks that span the entire globe. These are the representation of the satellites around the Earth. They're a little represented a little bigger than they are, but that's basically how you can imagine it. So we have this communication layer around the world that lets us telecommunicate with some person on the other end of the planet. And actually what now matters is not geographical space anymore, but it's the network structure. So communication flows basically enable and define what is space. So some people call it the death of distance, of geographical distance.